Hello, and welcome to Genomics in the Cloud Book Club, Week 12. I'm your host, KT Picard. In today's meeting, we'll be discussing Chapter 11, Running Many Workflows Conveniently in Terra. We introduced this workflow engine, this ecosystem, if you will, to kind of pull together the work that we've done over the past few chapters, specifically around running many sequences in parallel. We'll go through the steps to get there and have an open discussion for your questions. Here now is Chapter 11. So let's start with an overview of the Terra platform. And what you're looking at is this entire ecosystem that includes the Terra and being built on top of GCP. It adds a number of pieces, most notably the ability to run a WDL server in the background, which then parcels out jobs using Cromwell all in the background. I should point out this is entirely independent of the VM that we've been using throughout the book that we set up in Chapter 4. Terra sets up VMs as required and also then writes to Google Cloud Storage, as you can see on the right. In the middle, we'll talk a little bit later about how the actual jobs are submitted and dispersed. The last thing I'd like to point out is that it's inclusive not only of running these analyses, but also of analysis itself. And so you can see on the left there, the use of Jupyter, which we'll come to next week. Joris, one of our members, will present. And then also some other packages like RStudio that are becoming more available on the system. So to get started, you'll want to go to app.terra.bio, and this is the first screen that you'll see. You'll use your same Google login account, and there's a screenshot there. I'll walk through these in real time in a little bit. Once you've signed in, you'll see this registration form. You can put in your name, and most importantly here, the contact email can be different than your Google email account, so that if you'd like to send email notifications to a different address or to a distro email distribution list, you can do that. After registering, you do need to put up some billing, some plumbing for the billing, and we'll walk through that on how to connect your console with Google Cloud into Terra. We'll talk about this in just a moment. And again, this is the final step to connect your Google account into Terra. There are multiple ways to do this. The book goes through several, including if your institution has access to Terra. Next, we'll copy a preconfigured workspace inside of Terra and show how that's done. These workspaces include the full workflow suite of WDL and its subtasks. We'll walk through that. Inside, you can see some tabs across the top. We'll walk through the different workflows and getting us through. This one is a repeat of the last chapter where we discussed the haplotype caller. There's some information about what you're about to run, and we'll look at that. And then we'll actually run the analysis using the inputs that you see on the screen. As I mentioned, here's a way that workflow submissions happen in Terra. Behind the scenes, then, a number of things happen similar to what we did manually in the previous two chapters, meaning that we brought up Docker, we brought in an image of GATK, we either started Cromwell manually or ran it through WDL Runner. There's the PAPI interface that farmed out jobs, as you can see in the middle. And then you can see the various worker VMs that are started from the server Cromwell. The data then go to a Google bucket that you have access to. We'll talk about the permissions and the billing of that. That's important as well. And the scalability of this is, I guess, almost infinite. And we'll walk through some of that. It's really impressive. Next, we'll go through a variation of this, looking at ability to pick out specific files. And this is where we'll pick out, in a trio, we'll pick out a couple of different things. Introduce the concept of of workspace and this. These are some generalizations that are kind of object-oriented that allow you to refer to a workflow in an abstract way, enabling you to make a change in a WDL file that then would refer to other workflows without having to go in and manually edit and change everything. So in this case, the Docker image could refer to a different Docker image across the board, and you wouldn't have to go and individually change individual files. As I mentioned, then we'll go into a specific sample where out of this trio, we'll select the father and the mother, and we'll open with a workflow. We'll select that and grab the haplotype collar, and we'll do a scatter on that, and we'll monitor that inside of Terra, and we'll talk about how the haplotype collar parcels that job out into different processes called shards. We'll talk about how this is all timed, and you can see how the different pieces fit together. If you run the same thing twice, it has an optional caching mechanism, so it saves your work from before, and in some cases puts pointers to it the next time you run it. This diagram shows that we're using those inputs, and then as you see here, if you tick the box that says use caching, if you can use those inputs a second time, then it will do so. And then we'll go to the whole enchilada. This is, if you remember from the last chapter, Mathieu walked us through the whole genome analysis pipeline. It was the mystery workflow number 2. Now we're looking at that same workflow inside of Terra, and we'll talk about how you can run this. A little bit about the workflows and sub-workflows that we have been introduced to in the last few chapters and how they all fit together. What's nice about this is that you're now no longer having to do this through the command line. It's all wrapped up for you very nicely inside of Terra. Same idea as before, a timing diagram, it's just that this time we're doing it at much larger scale. Finally, a word about downloading data or not. You have the ability to look at the data sets and bring them onto your own local system. Terra is very transparent about how much it will cost to download that. The egress fees are known to you. And this kind of dovetails into the next week's call, which is doing the analysis inside of Jupyter. And so it may not even be necessary to download the data sets onto your local system. You certainly can, but then we can next week show how those fit together inside of analysis inside of Jupyter. Okay, so here we are at app.terra.bio, and this is the platform that we'll be doing the work in. Up on the left here is some people call a hamburger menu. The icons are similar to the ones used inside of GCP, so they operate similarly if you open it, and the icons themselves are modeled. The user experience is modeled after the GCP console. So the first thing you do here is log in with your Google account. As you saw in the one of the previous slides, I've done that. And inside there, the next thing we have to do is put the billing plumbing in place between Terra and the Google Cloud Platform. So let's go ahead and do that. By the way, I'm skipping the step where I logged in. I put in my name and my email address where I wanted my notifications sent. So we'll jump over to the Google Cloud Platform. I'm just changing tabs. And over here in this menu, I've selected the billing option. And once I'm in billing, I can manage my account and add the information that's required. I'm clicking on the manage link, and this is showing I need to add Terra into the billing information. And this is what I've done here is it's Terra-billing Terra-billing at terra.bio. It gets changed to Terra-billing at firecloud.org. But the way you do that is you click on this add member bit right here, and this is where you type in Terra-billing at terra.bio. And you'd want to select a role. I found that it was important that you select the billing account user rather than the administrator. So it's noted in the book, but just to highlight that. When you click on save, then you're asked to put in a name for the project. I've done that before, so you can see I called mine Start Codon-Terra. So now that we've done that, we're saying that we're allowing Terra to use the money that's coming out of my Google Cloud Platform credits. I jump back over into Terra, and there I go into the billing, and this is where I set up a new billing project, and I'll just call one, I'll call it test, and this is where I set up, this is my billing account is the one that's coming from Google Cloud Platform. I click on create billing project, and that would create a new billing project. Again, the one that I just created before was Start Codon-Terra. And then you can add users to this if you want to add other people that could use that Terra account. This is the place where you do it. Okay, so now it's time to move into the world of workspaces. We're going to go into the library, and in this case, the showcase, where we can get access to the Genomics in the Cloud workspace. And these are examples of cool and groovy workspaces that you might want to check out. We'll come back to the whole genome analysis pipeline in just a moment, but I'm going to find the Genomics in the Cloud one. So I'll just look for it. There it is, Genomics in the Cloud. So we click on that link, and this is the one that's specific to our book. And so you go into that workspace, and you'll see a number of tabs across the top, the dashboard, the data that goes with it, the notebooks, which we'll cover later, the workflows, which we'll cover in detail, and the job history, also something we'll cover in detail. So the model is similar to GitHub in the sense that you need to clone this workspace into your own personal workspace. And you do that by going over to the 3 dots on the right, and you click that, and you select clone. And when you do that, then the workspace is cloned into your local workspace on Terra. It ends up here. It takes a few minutes. I did it beforehand, so you can see. If I now go into the file and I select workspaces, this is the Genomics in the Cloud workspace. You can see here that I brought in before. Let's go into it and take a look at some of the. It looks just like the page before, except now it's yours, and you can play with it. So from here, we can start to use the pieces that are inside. We're going to look specifically at the workflows. And this is, again, from the previous chapter where we used the scattering method for the haplotype caller. The first thing we'll do is go into the file paths workflow. And this is showing the various pieces that are available. Down below here, you can see the inputs to, I'm on the input tab here. These are the inputs that are going into this. A lot of these things we hand typed before, or they were in JSON files. Indeed, these bits of information are coming from those JSON files from the previous chapter. The difference, though, is that it's very nicely laid out, and we've got this key value pair idea. The difference is that we've got some types that are assigned to it that help us understand what it is that we're, the kind of string that we're using, or the kind of file that we're going after. So that's our first bit, and it's actually possible to go directly into this. Before I do that, just a few more, just a little walk around the park here, some information about this workflow. I'm going to use the file paths that are defined below. I'm going to use call caching, which, as I mentioned earlier, if it's been done before, it won't do the same thing twice, and we'll show that in just a bit. And something I haven't played with about deleting intermediate outputs. So that's if I click on Run Analysis, it's going to ask me to confirm that, and that will launch this workflow, and we'll get us right into it, and we're off to the races. We're off and running. I'm going to go into the job history for this workspace and show you. I've done this a number of times. There's the latest one that I just submitted, and it's going to be running in just a moment. But let's go into previous ones. The first one, for example, I ran here. It's tempting to click on the submission ID. It's actually a lot more helpful to click on the submission itself. So you click on that. And one of the things I found most interesting is to use the timeline, which you get to through this job manager, which is this icon here on the right. If you haven't authenticated, you may have to. I've authenticated previously, so it's all in place. So here, I've clicked on something called timing diagram, which is one of the tabs here on the bottom. And this very nicely shows what happened and when it happened. And so, for example, this one in purple is showing that it's pulling GATK from the Docker hosting site, and it's in 4 different shards or instances. And then here's the second part of pulling again, and then you can see the actual run times of merging the VCFs and the rest. This bit here at the bottom was me. There were some issues that I had with billing that I didn't have set up correctly. So you can see that it kind of sat there for a while until I figured that out. You'll notice, especially though in subsequent versions, the pulling doesn't happen, and we can demonstrate that in just a sec. So I'll go into the job history. I ran the same thing again, just to see what would happen. And we'll go back into that job manager and selecting the timing diagram. And what you'll notice is the colors are different because it's spending all its time cache reading the previous attempt. You'll notice that it doesn't have any of the loading the Docker images because that's been done before. So it's rather clever about the way that it uses previously computed resources to minimize the amount of time that you're spending, getting the job done. The outputs then, you can click on this and this would take you directly to the output. If I click on that, it jumps into the file browser. And this is, if you haven't seen this, this is the Google Cloud Platform browser. It's the web version of the equivalent would be using GSUtil and going into your bucket and taking a look. Difference here is that the bucket is not the one that we created from before, but a bucket that's created on the fly by the submission. But you can see here, there's the end product, the merged g.gcf file. So that's pretty cool, but we can move on and look at this a different way. In the book, the second part is to use the same workflow, but use something called the data table. And this gives us some more flexibility or control over the samples that we select. In this case, the second radio button is checked or selected, and it says use the workflow with the selected inputs. We're selecting something called book sample, and we'll go into the data here, and we'll select specific rows to process. And in this case, in the book, we're selecting the father and the mother. And it's just an example, but it shows us how we can give more. If we, again, this could be very large and it allows us some control over, especially if we're doing some debugging, a smaller number of samples to run. One of the most important things here, though, is that we've abstracted this concept when we're using the data sets. We're now, you saw before, it was actually referencing specific Google, I don't know, like the GS for storage, or it was referencing specific URLs for the Docker image. Here we've abstracted it out to workspace. And the advantage here is that if you needed, again, to make a change to your overall GATK Docker image, you could change that at a higher level, and then your sample sets then would use the attribute in the workspace, rather again having to go through and change a bunch of different files. You can do it at a higher level, and those then cascade down using this workspace concept. If you've done any object-oriented programming, this is a very familiar concept. It's just referring to this specific instance of the workflow. So again, I'm using call caching, and I'm going to run that, and off it goes. And we can go back, and you can see we just submitted the father and the mother. We'll go back to our job history. The one that we ran just a few minutes ago is finished. This is the one that this is the job that I just put through in this workspace. So that's off. I can show you a previous run of that software. I'll just grab that one. And we'll go into the job manager again. I really like the colors inside the timing. So here's the timing diagram. And this shows what happened along the way. So here's the caching of the call reading, and here's a polling for this is polling for something for the first time, and the container set up and the rest of it. So it's again very nice view of the processes. It took 5 minutes to run this particular step, and again the outputs as before are there. Okay, well that gets us through the first haplotype caller and using that. Let's see, we'll go into cloning now. We'll work on the next the full germline caller. But before I go there, I just wanted to talk a little bit more about cloning. There's a note in the book about how cloning works. When you clone something, you're actually cloning the data. And so it's important to remember that when you're moving from one workspace to another and cloning it, you're not actually making a copy of the data, but a pointer to the data itself. So if you thought you could save a copy of your data by cloning it and then deleting the original, it doesn't work that way. And so that's a note in the book that I think is an important one. Okay. So let's go back to our next workflow, which is around the whole germline single workflow. It's in the showcase, and let's see, here it is. It's the whole genome analysis pipeline. So we go into that one. For the purposes of today's meeting, we're going to be using a previous version of this. This is a more updated version, but the one in the book uses this link here. We'll switch to that page, and you can see more information about how to run the workflow. And this is information that's largely in the book, but you can, here it explains what it does, and the inputs and the outputs. You can see that there's lots of things that come out of this. And this is, again, the production run that the Broad uses. Just like in the book, though, it's using the sample, the mother sample 12878, and also a smaller version of it. And when you use those samples, it gives you a sense of the cost of how long that will take. So again, to get there, it's off to the right, and the 3 dots, we click and we say clone, and that brings in a copy into your workspace. I did that earlier. And in my workspaces, it's one that I called whole genome analysis pipeline copy. So I'll go in there. And largely the same. The data has the samples that we talked about. There's the mother and the smaller version of the mother for debugging purposes. The workflows then, similar kinds of workflows, is just that this time we're doing everything from alignment all the way to calling. And in this case, we're going to use the file paths because it works well. So I'm going to jump into that and show you the same kinds of things. This is showing you the GitHub, the location where the code is actually being pulled. In some instances, you have different versions available, and you can change those, and it updates the software appropriately. I'm using the inputs that are defined by these file paths below. And some of these things should look fairly familiar. We talked about preemption in the last chapter, and so these are the other data pieces of data that are coming together to make all this work. The outputs then will go into the files that are defined here. And let's just, this should be running. But let's just go ahead and fire off another one for fun. And we can see maybe some of the differences. So in this workspace, I had some trouble the first time I ran it, but I did run it and it finished last night, my time. So we'll go in there and take a look at what that looked like. Going into the job manager then. And here are all the steps, the workflows. And if you click in any one particular workflow, then you'll see the subtasks that were part of that. The tasks are scattered, and we can see that in the timing diagram. So we'll see 24 different versions of that as we move along. And then this is the next step in the workflow process. And you can see this will just move from left to right as we progress in time. So here's sorting, which takes a while. And here's the base recalibration step that we're familiar with. And here's applying base quality scores. And here's the rest of it. We're gathering the BAM files together. So that's just, again, this is just one piece of the entire workflow, but it gives you a sense of graphically how all these things come together. Previously, this was really challenging to get a handle on of what was going on. And in this case, now we have a very good sense of what it looks like. So the outputs then are in these files again. I'm using the file path directory. But again, here's my data inputs again that I used here. Let's go back finally to the job manager and see the job that we're running. Oh, good. So I'm going to click on the filter that says running, and this is the one that we just fired off for the whole genome germline sample. And we can go in there and we can see that it's aligning the unmapped BAM. If we go into that, we can see the tasks that are running. Any reason why read groups were 24? That's an interesting coincidence.
Oh, that's just because of the level of multiplexing that the sequencing facility uses. I don't know what is the logic behind that. Presumably it fits, you can fit
okay.
some number of samples on, you know, the overall plates. You can have multiples of, you know, you're playing with powers of.
So it's lanes. It's just wonderfully coincidental.
Well, it's a little more than just the number of lanes on a plate, because within the same lane we mix in, so we multiplex multiple samples. So the same sample is mixed in with a bunch of other samples within a lane, and it's also spread out across different lanes with different samples.
Sure.
And then all of that is demultiplexed, and it has to do with part of it is risk management, so that if you have one lane that fails, you still have data from that sample from enough other lanes for the analysis to be workable. And some other considerations that I'm not privy to, but that is something that they do kind of systematically.
Great, well, thank you. At the end of that workflow, then we get these cram files, and this is again just a sense of where things end up, and I think we'll leave it at that. Next week we get into there's this issue around notebooks. We'll cover that in more detail, or in Jupyter, where we actually can get into analysis. But I'll bring up the slide again. I was just completely blown away with the capabilities of Terra. Since you're here, Geraldine, would you like to spend just a moment talking about? I've seen you tweet about some more, even more things that are recently part of Terra.
Oh yeah, so so here we're showing kind of the basic capabilities of the platform in terms of accessing data, managing data, and then running different types of analysis modalities. And in the book we described batch workflows, of course, with Cromwell and Whittle. We also described Jupyter notebooks, which is what you'll be tackling next week. Since then, the development teams have added capabilities for using RStudio and Galaxy. So if you're not familiar, RStudio, of course, is the very popular data science development interface for R. And you can do, there's really a lot that you can do with RStudio in terms of, you know, the downstream analysis. Once you've processed your data through the pipelines, typically you'll do some more interactive analysis, and RStudio is very popular with people. Jupyter, it's interesting. Jupyter Notebooks, I think, is I love it for teaching and for distributing, a canned method where I want to show somebody how I did something. Jupyter Notebooks is really powerful for that. It can be a little rigid and frustrating if you're trying to develop a new analysis and you're just exploring things. And for that, RStudio is just, that it's probably the best or one of the best in data science if you're developing in R. And so we have an alpha integration of RStudio. I've used it. It's really pretty solid. Honestly, I think it should be a beta at this point, but the product team is just very skittish and they don't want to overpromise. So I respect that. And the other one, Galaxy. Galaxy is a project that has been around for many, many years. I want to say at least 10, probably more. And the goal there is to provide an interface for people who don't have training in command line and who want to be able to use essentially command line tools without dealing with command line interface. And so Galaxy provides an interface for managing, I would say, smaller amounts of data compared to kind of the native data tables and workflows that we have in Terra. Galaxy is kind of geared towards smaller data sets. But that might just be my ignorance talking. If it's better than that, then I would love to be corrected. But it provides, one of the really neat things with Galaxy is that it has kind of this library of tools that have been wrapped into the interface and that are available out of the box. And now you can, so we have an alpha integration of Galaxy in Terra, and you can basically spin up your own personal instance of Galaxy. So instead of logging into a shared Galaxy server where there's a lot of other biologists who are trying to get work done and your jobs get queued for a long time, here you just spin up your own personal instance. I'm sorry if there's a little bit of background. Children are home because it's a holiday. Anyway, so you spin up your own Galaxy instance, and you have access to all of the tool shed and so on, and you can knock yourself out. That one I would say is kind of deserving of its alpha designation. There's still a few things that are not fully connected. Some wires aren't fully connected. So occasionally clicking on something will turn up page not found and stuff like that. So that one definitely has more rough edges. But for anybody who just wants to use the core functionality, it's surprisingly straightforward and it's really neat. And there's blog posts. I recently wrote a couple of blog posts on both Galaxy and RStudio that show kind of the basic walkthrough, basic usage, if anybody's interested. And so I guess we'll have to add these things to future versions of the book at some point.
Sure. And I'll add links to your blog posts in the additional resources. I hadn't put that together yet, so we'll include those too. So thank you. Yeah. Well, let's open it up to questions to the group. Questions about Terra, your experience with walking through the exercises in the book, or other questions. Well, the one that's on top of my mind is around cost. The thing that I was most impressed with is it has many of the features of commercially available packages. There are other bits that you're probably working on that are, around governance and around regulatory issues that are important for some people. But for folks like myself, I found this wonderfully useful because it takes what we've done and automates it. And what I really like is the integration of best practices into the workflow itself. So as the best practices get updated, I don't have to go hunting for that workspace. You just bring it in, and again, I'm pointing at cloud data, so it's very simple. I found that probably the most elegant part of Terra is the tight integration between best practices workflow and the data itself. But I'm just wondering, is this something that, if you could make a comment on this, is Terra something that will continue? Right now, I'm not seeing a cost associated with it. What's the future look like there? Any guesses?
The future of Terra. That's not a small question. I mean, we recently started a partnership with Microsoft. So that's the biggest news on the Terra front is Microsoft joining the team, and so they're going to help us with some of the developments. It's kind of a multi-purpose partnership in some ways. So part of it is to develop Azure support. So we want to have a future that is multi-cloud. We want Terra to be able to be usable on multiple clouds. Terra itself will probably continue to run on Google where it sits right now, but you'll be able to, the idea is that you'd be able to log in with your Azure credentials, have your data on Azure, and execute workflows against the Azure compute resources. So that's kind of the basic thing, but the partnership goals go beyond that. We'd also like to flesh out certain functionality that's been on the roadmap for a while, and so having Microsoft's help they have, of course, a huge amount of experience in delivering, I would say, software and kind of enterprise solutions and things like that. We're looking forward to beefing up certain parts of the functionality. It's also going to help us in terms of getting deeper into the healthcare and biomedical ecosystem, because a lot of what we do intersects, of course, with healthcare applications of genomics and other omics technologies. But to make that usable for folks in the healthcare sector, we need to be able to deliver on the kind of enterprise side of things. And so that's where having a partner like Microsoft is going to be hugely helpful. So that's the biggest, biggest thing on the horizon for Terra. In the meantime, though, there's a number of usability projects, usability improvement projects that are underway. Some things are just small, like making it, we're exploring using pop-up queues and things like that to help people navigate the interface when they're new, help kind of do guided walkthroughs. So you don't always have to read through a huge page of text or watch videos. We want to give assistive cues within the app itself. So that's one of the big areas that we're working on. Some things are, continuing to refine how you work with workflows and the data tables. We know, so I have very mixed feelings about the data tables, because on one hand, they're such an incredibly powerful feature in terms of allowing you the flexibility and power to run on huge amounts of data. But at the same time, the way they're presented right now is still challenging for a lot of people who come to the app. We know it's one of the things people tend to have a hard time wrapping their head around. And so we're doing some work to make it easier to understand how they work, and also easier to load data into the data tables. Because right now you have to make TSVs, load files and stuff like that. If you're bringing in your own data, which is something you'll cover in chapter 13, that can be a little painful. It's not difficult as such, but it's just like tedious, and we'd like to provide a better experience. And on the register of data, one of the things that's really cool about the platform is that we work with so many other groups who are data custodians, so that once you're in Terra, you can access like this huge library of data sets. Some of them access controlled, so we manage the authentication, stuff like that, some of which are open access. The biggest problem in that area is harmonization, because every project has kind of their way of structuring the metadata and stuff like that. Technically, you can bring in data from different data sets into a single workspace and then analyze them all together. The problem is that if things are called different names, like you can have BAM files, but on one side they're called, my BAM files, and the other one is processed BAM file or clean BAM files. Like the platform doesn't know that these are the same things. Or you could have two data sets where you have two different things that are called the same. And if you don't do anything special, you would group these things and end up combining things that are apples and oranges. And so we have a group that's working on data interoperability. So basically kind of producing a model for how to combine and harmonize data from different sources. And we're working with, teams at GA4GH to make sure we aim for standards that are widely usable, and that it's not just yet another niche implementation. So there's a lot of work on that side to really realize the promise of the data ecosystem. The idea is to be able to federate these large data sets. Right now, you can do it, but it takes a lot of individual work of harmonizing things manually. We want to make it so that you don't have to do as much, and that to have an interface that kind of guides you and helps you and does a lot of things by default. And so that's one of the things that is on the roadmap. I can't give any kind of timeline.
That's okay.
But that's all the kinds of things that we're working on in general.
And how long have you been working on Terra? How long has it been up and running, Terra.bio?
Oh, well, technically we had a thing before Terra that was called FireCloud.
Okay.
And we wrote, most of the book was in FireCloud. And then I guess, was it last year? No, it was 2019. I guess 2019, we launched Terra as a Terra.bio thing. Basically new branding, same underlying infrastructure, but we started working with Verily, which was our first kind of commercial partner. And at that point, FireCloud itself lives on, because FireCloud was started as a project that was funded by the National Cancer Institute of the NIH. And we've continued to work with them. So FireCloud is the portal for all the cancer data, TCGA and so on. So we still work with them, and FireCloud kind of continues as was originally intended as a project of the NCI. But Terra is kind of the more generic platform that was born from that original idea, if that makes sense.
It does.
So FireCloud sits on top of Terra, but now we have other kind of branded entry points, like the Anvil, which is an informatics lab space. There's visualization in there. I forget which order the words are, but it's the Anvil. And that's the combination of DocStore, the Gen 3 data repositories from the University of Chicago, and a few other kind of collaborators. Well, Galaxy and RStudio are part of the Anvil collaboration. So we have multiple complementary and overlapping collaborations. So Terra itself, to answer your question more briefly, started in 2019, but we had been working on the predecessor, the underlying platform, probably since 2015, I want to say.
Wow.
Pretty much since we started moving the Broad's processing pipelines to the cloud, and as part of that, so the initial part was, Cromwell, getting Cromwell to work on Google Cloud and all of that, but then came the vision of wrapping these services in an interface that would enable researchers not to have to deal with Google permissions and Google buckets directly and stuff like that. You still have the flexibility of doing it if you want to, but we want to provide these kind of managed services so you don't have to run your own Cromwell and stuff like that. And hopefully running things in chapter 11 is less painful than in chapter 10.
Was, the first time I've seen Terra, and I just blown away by the power and the things that can be done with it. And so, the first thing I'm wondering is this, type of, big data analysis would be useful for lots of other domains besides, computational biology. And I'm wondering if people are using Terra for that. But then the second part is, this sort of approach is so useful. You'd think there'd be other platforms out there that other people have developed for other domains that might be useful for computational biology too. And I wonder if, just wonder, how much crosstalk there is between people working on big problems like this.
That's a great observation / question. I'm aware of one other platform that's kind of equivalent in the sense that it's an academic project. It's called PanGeo, and it's for geosciences, basically. I'm not very familiar with it in detail, but I occasionally do PR with partners. I was invited to speak at a Google User Days one time, and one of the other speakers was representing the PanGeo platform, and it was really interesting because I got to go first and kind of explain the problem that we're solving with Terra, and then kind of outline the solution. And then the guy right after me, it's like, okay, basically our problem is the same as what Joel just explained. And so we built a thing that's kind of similar, but it's called PanGeo. Their implementation is pretty different, but it is the same idea of, let's not copy data all over the place. Let's make these central access points. Let's bring people to the cloud so the data can just sit there, and let's build some interfaces that are tailored for the type of research that people are doing. I think Terra just started earlier than PanGeo, so I think we're a little further down the road. We're at the point where we're looking. I think they have still more command lines focused stuff. Plus the visualization, they have amazing visualizations. We're a little further on the road, I think, of supporting arbitrary applications. I mean, that's one of the things we'd like to do, or aiming for, is that you could bring like whatever niche application you need to use for your research, that you could bring it and plug it in, given some basic requirements, and just fire it up in the cloud. But that's further down the road, because doing generic things is a lot harder than doing specific things, because you have to think about a lot more different eventualities. And so that's something that we hope, because we don't want people to be locked into any specific, we don't want to be in the business of choosing what tools people should use for this kind of science, right? Right now we kind of have to pick like what's popular, what's useful, and so on. But in the future, we'd like people to be able to run just whatever they want, and also make available to their users. So we already have the concept of like community contributed environments, and we have a few where developers have made basically Dockers that include all the stuff for running the software they make, and you can go and plug that into the system that runs the Jupyter notebooks, which we'll talk about next week. You can actually plug in these customized environments that already have preloaded libraries and a bunch of things. In some cases, visualizations. It's still very focused on R and Python type packages, but we're looking at expanding that, also making it possible to run your favorite R Shiny apps, because we know those are super popular. So that's one of the things we're looking at. I'm trying to be very careful not to overpromise. This is I know this is recorded, but it's off the record, sort of. You know, these are the things that we're working on and thinking about, and how we're thinking about those problems. But you're totally right, Richard, that there's the underlying problems are the same, and the idea of this solution, as we become more and more generic in terms of what we support, I wouldn't be surprised if people just opportunistically started using it for their own thing that's not biomedical science. And that's okay. That's okay. I mean, we won't be able to support their particular application in the sense of helping if something goes wrong, if it's a completely different domain. But if people find it useful and are able to use it in that way, I think that we'd be very happy with that.
Thank you, Geraldine. Yeah, I think the idea of extensibility has been a method of success for a lot of in medical software. That idea of being able to make contributions that are used by others, it's been a tremendous draw to a number of software programs in different domains. I'm thinking of oncology in particular. Yeah, I can see that being a path to success or continued success. Really enjoyed getting to try it, and thank you for the exercises to get us there. So we'll call it a day for this meeting. We'll continue the discussion next week. As we mentioned, Jupiter Joris, one of our members, will present that. After that, Adelaide will talk about making Terra your own and making your own workspaces inside. And then finally, our member Matthew, who came back and shared with us in the last chapter of the mystery workflows, concludes the book with a chapter on reproducibility. So thanks everyone for joining today for Genomics in the Book Cloud. I always do this. The Genomics in the Cloud Book Club. We'll see you next time. Thanks everyone.